Computer numerical control technology has been one of the top innovations of the last few centuries and is applicable in engineering processes. It has completely changed how manufacturing processes work. The level of automation it brings has provided a gateway to focus on skill-based labor instead of physical labor. The majority of metal and plastic products are made using both CNC machining and molding techniques. It implies that this kind of technology is crucial for the industrial sector. Many production-related problems that cannot be resolved by conventional methods can be resolved by CNC machining. Industrial engineering, i.e., in the process of examining CNC machining production, the paper advances specific research techniques, clarifies the development process, examines potential areas for improvement in CNC machine tool production management, and successfully uncovers the production potential, lowering human requirements, improving enterprise unity, and giving powerful technological assistance. If you wonder what is computer numerical control and how it works, this video is the perfect place for you to know more about CNC. There will be information on every aspect of CNC, like its history, applications, components, advantages, and disadvantages. Without waiting any further, let us dive into the topic right away. CNC machining is a term commonly used in manufacturing and industrial applications. But what exactly is CNC? And what is a CNC machine? The term CNC stands for Computer Numerical Control. It is a subtractive manufacturing process that typically employs computerized controls and machine tools to remove layers of material from a stock piece, known as the blank or workpiece, and produces a custom-designed part. This process is suitable for a wide range of materials, including metals, plastics, wood, glass, foam, and composites, and finds application in a variety of industries, such as large CNC machining, machining of parts and prototypes for telecommunications, and CNC machining aerospace parts, which require tighter tolerances than other industries. Note that there is a difference between the CNC machining and the CNC machine. The former is a process, and the latter is a machine. A CNC machine is a programmable machine that is capable of autonomously performing the operations of CNC machining. CNC machining as a manufacturing process and service is available worldwide. You can readily find CNC machining services in Europe, as well as in Asia, North America, and elsewhere around the globe. The origin of CNC. John T. Parsons is credited with developing the first numerical control system. While working as a machinist at his father's company in the 1940s, Parsons begins working on innovative ways to build helicopter rotors for the nascent aerospace industry. Teaming with Frank L. Stulin, the two developed a method where one machinist would read the coordinates along an X and Y axis to two other machinists, who would then make the cut. From there, they teamed with researchers at the Massachusetts Institute of Technology, MIT, to develop punch cards that could be programmed with enough points to provide for fully automated machining. The real advent of CNC machining came in 1959 when the MIT team successfully demonstrated an entirely automated machine that produced aluminum ashtrays. This concept laid the groundwork for the further development of the CNC machine. CNC components. Computer numerical control technology systems is an assembly of 4 different components. First, the CNC controller, also known as the Machine Control Unit, MCU. It is the brain of the CNC machine. It reads the CAD software programs and provides commands to the machine tools, and it gives every automated command like the movement of the arms, rotation of drills, etc. Second, the CNC software makes the communication mode between the manufacturer and the control system. Computer-aided design, CAD software, helps design the required parts' graphical representation. Third, the input-output, I/O. Input devices include the keyboard, cursor, and mouse. These help the operators in the machine setup, while output devices display essential information such as machine status and errors. These include a display monitor and alarms. Last is the communication protocol, where the path through which information can be transferred to a CNC machine. For instance, once the CAD files are ready, they must be loaded into the CNC machine. The communication protocol can also transmit data from CNC systems to a central server. Uses of CNC technology. 1. CNC machining can be repeated. The best benefit of CNC punching is that once you set the design, you can make as many copies of it as your materials will allow. Whether you're making plaques, carved signs, decorations, or even car parts, once the program is in, you can just save it and reuse it whenever you want. 2. Dental equipment. Believe it or not, dentists are known to use CNC equipment for certain procedures, particularly for dental crowns. CNC services are often associated with wood or sheet metal, but they can make so much more. Since the equipment is precise, you can even use CNC programs to carve out dental crowns and implants. 3. Weapons. You may have heard of the controversy over 3D printers because of their ability to manufacture firearms without serial numbers. Well, CNC machines have been around for a lot longer and have had that capability the entire time. Not only that, CNC machines can even make modifications for firearms, including grips and other accessories. The only difference from a 3D printer is the amount of material you need to start with. However, it is illegal to manufacture firearms without a permit. But CNC mills are used in the manufacturing process for many firearm brands. It isn't only firearms made, the military and defense industry often uses CNC manufacturing for other weapons and equipment they need. The entire industry relies on CNC manufacturing for a lot of its equipment. 4. Construction. While this may come as no surprise, there are many times in the construction process when CNC punching can come in handy, some of which you may not expect. The amount of precision is hard to match by the most skilled carpenters, and there are certain jobs, especially when working on existing structures, that require a perfect fit. Other trades may find the need for this level of accuracy, including pipe fitters, plumbers, and even HVAC technicians. The reason is mainly that CNC technology can simply offer so much more than any other tool. They can act as a router, drill press, jigsaw, table saw, jointer, even a surface planer, and more all at once, with the ability to work on any material you can think of. It's hard to beat. 5. Transportation. This is a broad term, and that's because CNC technology offers such a broad service to the industry. Aviation, railway, and automotive industries all use CNC technology in some form or another because it offers such a wide variety of services. Railways and automobiles also need to be put together properly to ensure safety. When over 70 million vehicles are manufactured every year, automakers need to be certain that quality control is of the highest priority. 6. Research and development R&D across almost every industry will need prototypes as well as some degree of trial and error. That includes physics, chemistry, biotech, woodworking, and more. CNC machining offers the ability to take on any idea from your head and make it into reality with expert precision. Since its inception, it's been used to develop accurate prototypes for almost every field you can name, and it continues to do the same today. 7. Niche manufacturing. The truth is that CNC machines can do it all. Anything that needs to be manufactured from the right volume of almost any material can be done on a CNC machine. CNC technology has upped the ante for manufacturing all different niches and styles and is only continuing to improve. No matter what your manufacturing needs are, a CNC can provide them for you. 8. Signage. Whether you're creating a small-scale 2D project or a more complex 3D signage component, a CNC machine can get the job done quickly and cleanly. CNC routers are capable of skillfully working with a wide range of materials, including foam, wood, plastic, acrylic, aluminum, brass, and more. Machines featuring a vision system will provide increased efficiency and accuracy for users needing to quickly register a toolpath when crafting signage or carvings. The ability to create ADA-compliant signage is also essential for many modern sign shops, requiring a CNC machine capable of intelligently producing results featuring tactile text, braille, character spacing, and more to comply with the complex ADA signage regulations. 9. Cabinets and furniture. Cabinet manufacturing is one of the most common applications for CNC machines, whether used to create customized or more standard pieces. In addition to cabinetry, CNCs help shops produce closet sets, shaker and raised panel doors, countertops, chairs, tables, and more with immense precision and unrivaled efficiency. Intricate cabinetry and furniture designs are easily brought to life via 2D, 3D, and 4-axis capabilities, delivering an elegantly smooth finish at the moment of completion. Reduce lead times, minimize material handling, and elevate the quality of your cabinet-making process through the power of a high-end CNC machine. 10. Aluminum and brass machining. Working with non-ferrous metals like aluminum and brass requires increased cutting capability from your CNC machine, in addition to a little more attention and preparation. But when done properly, it can save time and money in the shop while producing a superior result. Determining and utilizing the proper feed rate and spindle RPM becomes more important when working with aluminum or brass, as they interact a bit differently with the blade than other materials. 11. Prototyping and 3D modeling. Precise modeling and prototyping are essential to the success of the production process. Without that precision, you're not adequately able to assess the full potential and next steps of your concept. A CNC machine allows you to scan, copy, engineer, and reverse engineer components to help craft innovative and advanced products. The production speeds of CNC routers and CNC plasmas also allow you to accelerate project timelines as you quickly and accurately create lifelike prototypes to inform future decision-making. 12. Musical instruments. The precision capabilities of CNC machines are perhaps never more crucial than when creating musical instruments. Every component needs to be cut to exact specifications and made to interact properly to produce a beautiful range of sounds. CNC routers help musical instrument manufacturers produce large quantities of high-quality products on an efficient timeline, never sacrificing the performance of the pieces at any point throughout the process. CNCs also excel in creating one-of-a-kind instruments via one-time projects, so manufacturers can provide customers with unique result that meets their exact needs. The advantages of computer numerical control. There are many advantages of using CNC machines over manual machining processes. Some of these are speed. CNC systems can manipulate tools at a faster speed than humanly possible. Additionally, there are no breaks between movements. Error compensation. CNC machines can predict and compensate for errors by modified movements. This occurs in real time with intelligent machine calculations. Therefore, high precision is possible in materials with thermal or geometric defects. Safety measures. CNC machines have multiple measures to ensure operator and workplace safety. There are emergency stops that can be used if an unwanted event occurs. Customization. CNC programming is highly customized. Programmers can make the same CNC machine tool do many different things. For instance, a CNC machine can cut a solid sphere and a solid cylinder alike by switching to a different program. Self-diagnostics. CNC can detect and report errors even within itself. The self-diagnostic system can alert the operator immediately when an error occurs. Diagnostics can prevent accidents like overheating, program conflicts, workpiece damage, and machine breakdown. Compliances. Manufacturers have to meet with several compliances like ANSI and ISO. The precision of CNC technology helps them with meeting every compliance standard. Scalable solution. CNC systems do not have size limits. They can work on something as small as a screw thread. They can work on entire aircraft frames. Additionally, the production rate can be adjusted to meet the demand. Quality control. CNC systems come with inbuilt quality control measures. The sensors can inspect every workpiece and reject it if there is a failure to meet the manufacturer's requirements. Complex geometry. CNC can use complex tools and multi-axis machines to create very complex parts. It can even craft parts with internal geometry. Disadvantages. Cost. CNC machines are more expensive and require a greater initial investment than machines that can be operated manually. However, as this technology becomes the standard, supply is increasing, resulting in costs gradually decreasing. Skill loss. As the demand for manual machine operators decreases, fewer and fewer new students adopt those skills. This could eventually lead to the complete loss of long-preserved skills. Unemployment. Automation decreases the need for manpower, and fewer laborers are hired. That said, the need is now shifting to software engineers and mechanical engineers, and education and training will have to adjust to meet that need. Computer numerical control has been nothing short of a modern marvel. The capabilities of CNC machine tools have made them a must-have in every production setup. There are countless CNC machining options to fulfill your project requirements, regardless of how complex they might be.